In this talk on national soil carbon stocks with a focus on cropping, I'm going to present some recently released national soil carbon monitoring results, which gives a really good latest snapshot of New Zealand arable soil carbon stocks. I will focus on some of the differences between the mixed and the intensive cropping results and touch on the so what, why carbon is important in cropping soils. And finally, just highlight the importance of having those living roots. So New Zealand uses a national scale statistical model to predict the changes in soil carbon stocks with changes in land use. And it's assumed that it takes around 20 years to get to that new steady state. And in this graph, which shows the modeled assumptions around conversion to annual cropland from the reference point, which is the low production grassland. And it is assumed that would result after 20 years in a loss of 16 tonnes per hectare of carbon. So this model makes a number of assumptions, and there's been a large program of work led by Landcare Research to ground truth this. So the results from this work, which has been funded by the New Zealand Agricultural Greenhouse Gas Research Centre, are presented here, and this is the benchmarking or baseline work, which is now complete. They measured to depth 504 randomly selected sites across New Zealand, and 80 of these fell on cropping farms. The first point I want to make is that on average, the carbon stocks, and this is just 30 centimetres, for all of New Zealand soils, i.e. both agricultural and non-agricultural, came out at 90 tonnes per hectare, and this is a lot higher than other countries. New Zealand's high soil carbon stocks are attributed to its young soils and temperate climate. We can grow through things all year round. The next thing I'll draw your attention to is the soil carbon stocks just for agricultural land, which are 102 tonnes per hectare, about 10 tonnes higher than the national average. A few things are going on there, but good management does come into this. So on average, the cropping soils are sitting around 80 tonnes per hectare. And yes, we do have less carbon than the other sectors, but this is to be expected, and we'll touch on that a bit more soon. So the next step for this program of work is to compare these benchline samples with future sampling to determine whether the soil carbon stocks are at steady state or are they changing. So this is drilling down a bit more into some recent results coming out of just Canterbury, but there are some interesting take-homes that have wider applicability. So here there has been 100 sites that have been returned to every 8 years for about 24 years. So there's been 3 visits. The MAC is your mixed arable cropping, and the IAC down the bottom there is your intensive arable cropping. That horizontal line, that's the steady state line, that's where you'd expect to have reached in terms of carbon stocks after 20 years. And overall, the cropping at these Canterbury sites is at steady state. But when you drill down into the soil orders, there is an outlier, and it's circled there in red. These are the brown soils, i.e. the Lismore soils, pretty common in Canterbury. They are actually still in decline for intensive arable cropping systems. There was a further loss of about 0.34 tonnes of carbon per hectare, but this was just in the this was just in the intensive arable cropping, not the mixed cropping on brown soils. So in terms of decision-making across the rotation, I think it's helpful just to bear this in mind and why this might be, and the sort of things that we can be doing to ensure that we're not continuing this trend as a sector. But firstly, just to go back to why there's differences, there should be no surprises with these graphs. They do show a stepwise difference in the carbon stock, going from pasture to mixed cropping to intensive cropping. And this just comes with the territory of cropping. There's a lot of carbon that's removed during harvest. There's periods where there isn't those photosynthetic carbon inputs. There may be disturbance, and in some instances, there's just not that continual ground cover and living roots. And that continual ground cover, it is really important. Perennial grasses, but they have these really extensive fine root systems, and they basically just have a high amount of returns of carbon from those living roots. So yes, soil carbon can be a challenge in intensive arable cropping. Like I said, it does come with the territory, so it's really just a case of identifying where the opportunities are in your rotation to maintain or even, if possible, build soil carbon. And that's because it is important. Greater soil carbon does align with function and quality. Greater water infiltration, water storage, it remediates compaction, for example. This slide comes from what's adapted from HDB and Philip Wright, and it basically highlights that we know that avoiding traffic when soils are wet is not always possible, but when you have more carbon or soil organic matter, there are actually more days when you can get onto that soil because it stays friable for longer when there's greater carbon in the soil profile. But there is no one size fits all when it comes to building soil carbon. I'm going to touch in the remainder of the talk on a couple of things. First, reducing tillage. This is important for soil quality and functionality. We know that it reduces the risk of erosion and soil loss, but just want to make the point that in itself, especially on flat land, it doesn't necessarily build carbon stocks. And this is because the method of crop establishment influences how the carbon is distributed down the profile. So when you see papers that conclude that a shift from pasture to cropping is going to have less of a loss of carbon with no-till, you just need to make sure that the depth that they're sampling to is greater than 15 centimetres. If it's just at 15 centimetres, this can be misleading. And just a quick example of that, at the Chertsey establishment trial, we are seeing significantly more carbon in the top 15 centimetres under no-till compared with inversion tillage. But when you look at 0 to 30 centimetres, there actually is no significant difference between those two treatments with regards to the carbon stocks to 30 centimetres. So where does strategic cultivation come into this? So as I said, reducing tillage we know does improve soil quality, not necessarily carbon stocks. But at Chertsey, we are measuring greater soil structure and a better water holding capacity with the no-till treatments, which is resulting in high cumulative yields under dryland conditions, but not overall stocks. So what we're looking at now is trying to answer the question, what happens when you cultivate a soil that has been cropped for over 20 years without disturbance? Are you taken back to square one after a one-off inversion cultivation? What is the rate of carbon renewal where the no-till soils have that carbon from the surface taken down the profile where it may be better protected, and then you start to build that carbon again in a no-till system? What is that rate of repair? And ultimately, will this increase carbon sequestration compared to where it remains a no-till system? So I can't emphasize enough the importance of roots in this conversation. Plant roots, as I said, are continually adding that carbon to the soil. Residue is important for soil cover, and it is also associated with conversions to stable carbon, but the ratio between that stable carbon coming from living roots compared to residue is about 45 to 8. So those living roots are really key. And even short fallows, they can cause a substantial loss of carbon over time, and not only because you don't have plant roots adding that carbon, but those microorganisms are still utilising soil organic matter even when soils are bare. So conversely, having those short-term cover crops or trying to keep that ground covered, it can return carbon and improve soil quality. It's not to say that that's an option for every system. I'll just end by drawing your attention to the far focus, good soil is good business. There's multiple ways to look at this on cropping farms, and this far focus dives into 6 of the ways that are commonly used on cropping farms to improve soil quality and carbon. So just as take homes, soil carbon on New Zealand farms is high, and Canterbury, in the Canterbury example, is showing that carbon stocks in mixed arable systems are at steady state overall. But if you drill down to brown soils, we are seeing a continual decline under intensive systems compared to mix. Minimizing intensity of cultivations does improve soil quality and resilience, but we just need to bear in mind it doesn't necessarily improve carbon stocks. And just to end on the importance of keeping that ground covered as much as possible. Thank you.